Here's pre-calc. It's problem number 2-83. It says a periodic function is a function whose graph repeats itself identically over and over as it is followed from left to right. Periodic functions have periodicity, which simply means that they repeat at regular intervals. Many things you are familiar with also have this quality. Clocks have it, so do metronomes, and of course periodicals. The graph of y equals f of x is a periodic function. Use it to complete parts A through D below. So it says the period of a periodic function can be described as the smallest horizontal shift possible that preserves the function's appearance. What is the period of f? So I kind of wanted to look at it, at first I wanted to look at it like this. I wanted to look at it like that, but it's a little confusing because I wasn't sure. Well, I mean, I guess I can tell. I actually know that this is 0 because it's crossing the y-axis, right? So it goes from 0 to 5. So that's probably the easiest way to look at it. You can also look at it as going from 1 to 6. But I think just looking at this little piece right here. So the x, I'm looking at these x values, and I see that this is 5 right here. And that should make sense from what we've been learning about our sine and cosine. So that's a period, that's 5. And then it says, even though the points are not shown on the graph, what are f of negative 14 and f of 105? Explain how you determine these values. Well, I want to just show you if you can see this. So f of 14, I actually started going backwards from here because I know that I'm kind of suspecting that my f of x values, my y values, are either, they're probably going to be asking me about values that are these top ones, because aren't the top ones all going to be 4? Or these minimums, which are all going to be 2. So I can predict which ones are going to be 2 and which ones are going to be 4, because the ones that are going to be 2 are going to be multiples of 5. Like that's 5. The next time I hit a minimum will be 10, 15, 20, 25, 30. These ones are a little harder, but I do know that I'm hitting these maximums every 5 units or whatever, but I'm just not starting at the origin, so it makes it not be a multiple of 5. So like, I think I started counting. What did I do? I said 1. I started at 1 because this is 1, and then I counted backwards by 5 to get this one. So 1 minus 5, that's negative 4. And I made a little list. And then I went negative 4 minus 5 because that would be the next high point. Negative 4 minus 5 is negative 9, and then negative 9 minus 5 is negative 14. So I could just answer the question by going backwards. So I said that f of negative 14 was going to be one of these high points. So one of these maxes, these local maximums. So it's going to be 4. I hope that made sense. And then, like I was saying earlier, f of 105, well, I know all these low points happen every 5 units. Like this one's going to be 10, 15, 20, 25. So 105 is a multiple of 5. So I know that f of 105 is going to be, the y value is 2. So that's going to be 2. And then it says, is f of 2 equal to f of 50? Well, what in the world? F of 2 is not a high point or a low point. F of 2 might, if I look at my graph, might end up being right in here somewhere. And so we know we're going to hit f of 2 well, I was just thinking, actually you hit it twice, don't you? Oh wait, f of 2. Sorry, f of 2. So that's 5, and that's 1. So f of 2 would maybe, don't look at that, would start right there. And then it says, is f of 2 equal to f of 50? Well, I'm going to keep hitting this value every 5. So like I'm going to hit it there. I'm going to keep hitting it every 5. So like this first one, I would hit it at like, what's 2 plus 5? 7. And then 12, and then 17. Like I'm counting by 5s, but I'm starting at 2. Like 2 plus 5 is 7. And then plus 5 is 12, and plus 5 is, I don't know, 17. But I know that that number, that's never going to equal 50. So I think that's what it's getting at. Is it 50 is not equal to 2? Like, you're never going to get like a nice even 50 out of that. So we're going to say no. They're not, like, is it equal? No. And that's because I like how they said it. 2 plus 5 times any integer is never going to equal 50. Like, it's not a factor of 50. Okay, and then, oh, what a problem. And then letter D, use the idea of transformation of functions to write an equivalent expression for f of x in this situation. So just think of f of x as like just this one green wave that think of like that's one period, right? So I can just move that over and I can just take the whole thing and scoot it over by 5, right or left, and it would still be the same function. Just like I could do with sine, if I said sine, if I gave it a horizontal shift of 2 pi, it would just land right back on top of its own self. So this one can take a horizontal shift of 5. So that's why it says you can go f of x plus 5, because remember 8, that's h, it's the horizontal shift. Or you can shift backwards by 5. So the answer, I would answer that one, letter D. Well, you already saw the answer, but it's going to, I would say f of x plus 5. We don't know what the equation is. We could actually, it's kind of sort of has a linear thing going on. We could figure it out, but that's not what they're asking. We just give it a horizontal shift. I wouldn't say f of x minus 5, because you only had to say 1. I would just say f of x plus 5. I hope that helped.